Railway network, vast, diverse, and incredibly efficient mode of transportation. Long ago, the railway system has migrated to electric locomotives from the coal or diesel based locomotives. But still, electric locomotives are only 45% of rail energy consumption. Usually, the railway network operating on AC power run on 25 kV supply, but certain areas in Europe like Germany and Italy has 15 kV AC power supply. At the same time, mostly the trams operate at 600 volt to 750 volt DC source. Sometimes metro trains operate at 750 volts to 3000 volt DC source. While the high voltage AC, like 25 kV, is incredibly dangerous due to its ability to arc over long distances, 750 volt DC is often considered more treacherous upon direct contact. With the entry of electric locomotives, the percentage of deaths due to electrocution is 2% to 4% of all deaths caused by rail fatalities. The fatality risk comes from how direct current interacts with human physiology and its physical behavior during a fault. So let's try to understand which kind of electricity supply, AC or DC power, is more fatal and why. Welcome to Search Pulse, your go to guy for everything on engineering. And today we will break it down for you why 750 volt DC presents a unique lethal risk compared to high voltage AC. The first is lock on effect, that is, the tetanic contraction. The most critical difference lies in how muscles react to the current. AC current reverses direction frequently, 50 to 60 times a second. This vibration can somehow throw the victim away from the source. Furthermore, the voltage passes through 0, 100 to 120 times a second, offering a microscopic window where muscles might relax, potentially allowing the victim to let go. Whereas DC flows continuously in one direction. It causes a continuous severe muscle cramp known as tetanic contraction. If a person grabs a 750 volt DC conductor like a third rail, their hand muscle may clench, shut down it. The victim physically cannot let it go, extending the duration of the shock and drastically increasing the severity of burns and internal damage. The second effect of DC electrocution is electrolysis or internal poisoning. DC current causes significant chemical changes in the blood and tissue through electrolysis. Because the current flows in one direction, it separates ions in the blood fluids. This can decompose blood and cellular structures, creating toxic substance and gas bubbles within the bloodstream. This chemical damage can lead to tissue necrosis and kidney failure hours or even days after the internal shock, meaning a victim might survive the immediate incident but die later from internal complications. AC does not cause this degree of electrolytic damage because the reversing polarity cancels out the net movement of ions. The next is sustained arcing. DC arcs are notoriously difficult to extinguish. In AC systems, the arc naturally tends to extinguish every time the voltage hits 0, 100 times per second. In DC, the voltage is constant. Once an arc is formed, it will sustain itself and can be drawn out to considerable lengths, creating a massive continuous plasma blast that cause horrific thermal burns. This is why DC breakers are much larger and more complex than AC breakers of similar voltage. They have to forcibly blow out the arc. The fourth is ventricular fibrillation. While DC holds you tight, it actually requires more current to stop the heart than AC. The human heart is roughly 4 to 5 times more sensitive to AC than to DC. AC interferes more easily with the heart's natural pacemakers because of the frequency 50 to 60 Hz mimics the electrical signals of the heart itself, leading to fibrillation. However, because 750 volt DC prevents you from letting go, the exposure time is longer, making it likely that the current will eventually cause cardiac arrest or cook internal organs. The following is a comparison table between DC and AC electrocution. Have a look on it. In summary, high voltage AC is dangerous because it can kill you without you touching it. It can cause arc through the air and reach to you. 750 volt DC is more fatal in contact scenarios because it traps the victim and chemically destroys tissue from the inside, making survival and recovery more difficult even if the initial touch doesn't stop the heart immediately. So, next time when you are in a metro station, please follow the safety and warning instructions. Don't get too close to the railway tracks. It is for your own safety because your family and friends are waiting for you at home. Thanks for making this far. If you liked the video, please click on the like button and tell us in the comment section what did you like from this video and how can we improve more. If you didn't like the video, still tell us why. And don't forget to subscribe since more than 90% of our viewers are not subscribed. So please subscribe. Thanks a lot.